welcome to this month's webinar. My name is Mark Bursky and I'm a technical consultant here at Digital Carbon, specializing in SD-WAN, SASE services, network and security. Today's webinar, we're going to be discussing how we can basically master network management using the SD-WAN orchestrator or the VMware VeloCloud Orchestrator together with SD-WAN. So SD-WAN is, I guess everyone should know what the technology is by today. But basically today we're just going to go through the whole orchestrator, see how we can actually manage our network using the orchestrator, and what kind of monitoring security services we can actually use. So the SD-WAN orchestrator, or the VeloCloud Orchestrator, Edge Orchestrator, is a hosted service. It's a SaaS service hosted by VMware themselves. We can provide also an on-prem service, but 90% of our customers actually do take the hosted service. It's managed by us as a managed service provider, Digital Carbon, but it's a co-managed service. So basically, all of our customers, yourselves, will have access to the orchestrator. You can manage the network yourselves, and then we're always here for backup, or if you need any additional help, services, then you can always contact us, and we will also then help you and support you in regards to managing the whole service. So we're going to log into the orchestrator. Like I mentioned, it's a hosted service, so you can log into the orchestrator just by having a web browser, access to the internet. You get your own login. So we're just going to log in at the moment. And we go straight into the dashboard of the SD-WAN orchestrator. The actual orchestrator, or the Edge orchestrator, it provides many different services today. It's not just the SD-WAN. This is what we're going to focus on today. So the network management, the management of the WAN. But additionally, you also have access to all of your web cloud security. So if you have the web cloud security with the SD-WAN, combine that together, you get a full SASE framework, which you are able to manage from one single place. Additionally, you also have your remote VPNs. Today it's called SD Access. Before it was SD-WAN Client, but you can also manage all of your remote VPN users from the same location. And in the near future, you will also have your edge compute services. So you'll be able to actually turn up workloads, VMs on your actual edges themselves, and also manage it from this orchestrator. But today we're just going to focus really on the network part. This is about managing the network. There is a lot of security involved, but that will be in another webinar, which we'll be doing next month, which will be more focused on the security part. So the SD-WAN orchestrator, it basically manages your SD-WAN edges. So this is an SD-WAN edge, which you actually install on-prem at your locations. There is also a virtual appliance which you can install in your cloud services, within Amazon Web Services, within Azure, a virtual edge, and that is also managed from this orchestrator as well. So once we actually log in, we get our dashboard. Within the dashboard, you actually have an overview of your whole network. We actually see how many edges we actually have connected, if there's any edges which are degraded, or if you have any which are offline. So at the moment, you can see we have all 4 edges. They're all green, they're all connected, they're all working pretty well. We also have an overview of our hub sites. These are typically your sites which are within your data centers where you have your workloads. It can also be your head office or your cloud provider, public cloud or private cloud. Here we actually don't have any configured, because this network, our demo network, is actually configured as a hubless network, meaning it's not a hub and spoke network. It's basically a full mesh topology. On the right-hand side, we have our status of our links, which are our underlying links. Either they can be public links, internet connections, DIA, LTE, or private links, MPLS, or EPLs. Here we can also see that we just have 5 connections, and they are, at the moment, they are all stable. If we go down a little bit further, we have our list of all of our locations. Here we have our 4 locations. We can see the status are all connected and they're all green, which is really good. It also provides us information if there are any in a HA high availability mode, basically meaning if we have a active standby setup. At the moment, they are just all single boxed. If we have any clusters configured, these are more for hub sites, and also the link status. So we have 1 link for our Manchester site, but for a London site, we actually have 2 links. If we go down a little bit further, we have our overview of the most used applications. Here we can see a whole list of different applications. I think these are around 10 applications most used, and also we have a list of all of our edges or locations which are using the most traffic. As you can see, Manchester is using most of the traffic at the moment. A little bit further down, then it's just a quick overview of the number of profiles we have, the number of segments which we have as well, and also the software versions of the edges, and if there's any outdated software versions, or if we need to basically update any software. At the moment, all of our edges are up to date. A little bit further down, some information on if we have any virtual network functions, also if we have any AS pairs, and also if we have any non-SD-WAN destinations via our gateways. So basically, these parts we will go through later on a little bit. On the top, we have a list of different tabs, let's say. So at the moment, we're under the monitoring tab. So basically, we're just going to go through all of the monitoring parts at the moment. We're going to have a quick look at the configurations part, maybe a quick view, if we have time, over the diagnostics, and the services we'll probably won't have time. We won't actually look into under this webinar. So on the left-hand side, we can monitor a number of features. At the moment, we're looking at the network overview. We also have our security overview. This is the overview of our enhanced security features, such as IDS, IPS, or URL filtering, malicious IP addresses. At the moment, we don't have this enabled, and this will be another webinar which we'll be actually looking at to go through next month. Hopefully, you'll be able to join us for that as well, because we're just looking at the network part and managing the network. So if we go a little bit further down, we have our list of our edges again, and this time we can also have a look at the map, see how our edges are behaving. They're all green at the moment, which is good. We also have our different network services, the status of our network services. So, for example, our non-SD-WAN destinations. So these are destinations which are not part of the SD-WAN fabric. They are actually connected either through a VPN from the cloud gateways or directly from the edge sites. We also can have a look at if we have any cloud security services, such as a Zscaler or semantic cloud security connected. We also have a Zscaler subscription, see if that's connected. This is for the automation part. And then also our edge clusters, and also if we have any virtual network functions. Here we actually can see we do have a non-SD-WAN destination. This is configured from a cloud gateway. So a cloud gateway which is sitting very close to our Equinix data center, probably in the same data center. And it's basically connecting through a standard IPsec VPN from the cloud gateway to our data center. At the moment, it's not enabled and the tunnels are down, so we might want to have a look into that. Routing information, is if we have any multicast configured, if we have any BGPs configured, we are able to have a look through the status of that. At the moment, we won't really go into that. If we have any alarms, we actually don't have any alarms, which is really good because we don't have any problems. Any events, so here we can see that I have logged in recently, but it also gives you other events such as if an edge goes down, if a link goes down, then it's all reported here. If we have our firewall logs enabled, we get all of our logging here. For the firewall feature, then we can either log have the logging being done within the orchestrator itself, where we are able to have a look, or we can send the logs to a log server possibly, which we will actually go through the firewall features, like I mentioned in our security webinar, and then reporting as well. So automatic reporting, we can actually set up reports being done, which will also can be sent out by an email, monthly, weekly, depending how you want to set it up. What kind of events happened, what applications are being used. This is basically a reporting feature, which you can either have a look at the reports directly within the orchestrator or have them basically delivered via email. And the logs are PDF or CSV files. If we go back to the edge, so we're going to actually go down a little bit more deeper in regards to the actual edges themselves. So we're going to choose this first edge, which is our Manchester site at the moment. And here we get a dashboard of our site within Manchester. I'm just going to refresh this site at the moment. So I'm just going to refresh it. If we come back here. Okay. Here we go. So this is our Manchester location. And within the Manchester location, on the top, we have our status of our underlying links. Here we can see it's actually being connected only through a 5G unlimited wireless connection provided by Free in the UK. Just want to mention all of our edges in the UK are always provided with a wireless backup SIM card, meaning that you always have that available, and it's a pay-as-you-go service. So if you need the backup wireless, you basically call us, let us know, we activate it, and your edge will be automatically connected. Otherwise, we can also use this as a primary link. In this case, we are using the wireless link as a primary link, and it's the only link we have, and it's the wireless 5G connection. Here we can see the status of it. It's stable, it's green, it's good. We also can see the throughput, which is being used at the moment, and our available bandwidth. The available bandwidth is actually done by a bandwidth test. Every time we connect a new underlying link to our edges will automatically do a bandwidth test to check how much bandwidth is available, and then basically to prioritize the traffic, giving the prioritization based on the bandwidth as well. We have our alerts on at the moment, and then we also have our information about the quality of our underlying link itself. So if we have any latency changes, or what is the latency? The latency is actually measured from the edge devices to the closest gateway. If we have any jitter on the line, we don't have any jitter, which is really well, and that gives you a better quality for video and voice quality. And then if we actually have any packet loss, and here we do actually see we have some packet loss on this underlying link. If we go down a little bit more, we see all of our applications, or the most common used applications for this particular location. We then also are able to categorize these applications. So, for example, the most used category of applications is web traffic. Then we may have some tunneling and VPN traffic, SD-WAN management traffic itself, and then infrastructure and some media as well on the end. And then on the bottom, we just see what are the most common operating systems on the LAN side. Here, we don't have any information on that. And then the top sources, the top devices on this location, which are consuming the bandwidth. Here we can see that this device ending .10.11 is using most of the bandwidth for this location. So we're going to go through the tabs here on top just to have a little bit deeper dive into this location itself, just to see what is happening. So like I mentioned before, we did have packet loss. We can see that this packet loss has disappeared now. So its line is working a little bit more, but we actually go into the QoE. So this is the quality of experience. It will actually give us information how this line was behaving in the last, here we have 12 hours, and we can actually see our underlying link. The quality is pretty bad actually. So our free 5G unlimited wireless connection is all yellow and red, which basically indicates to us that the line is having some problems. We have an overall quality score here. It's out of 10. So it's 2.76 out of 10. So it's pretty bad. If we actually hover on top here on a particular time, so here we can actually see, okay, latency is pretty good. The jitter was good, but we have some critical packet loss on this underlying link. And because of this packet loss, the actual edge itself, so here which actually shows us that the upstream packet loss was measured at 1.13%. And because of this packet loss, the edge automatically started to enable forward error correction to mitigate these problems. So this is the power of the DMPO, so the dynamic multipath optimization techniques, which the edge can deploy. And there's a number of different techniques, for example, jitter buffering or negative NAC, error correction. So we have also duplicating of packets. For example, if we do have packet loss here, so instead of, if the bandwidth allows, instead of just having the traffic being sent, we actually, or the edge actually duplicates the packets and sends 2 packets for at least that 1 packet to get through to the other end. And after all of these optimization techniques, then after the quality dramatically improves. And this is what you can see here. It's all green. And the score is 10 out of 10, meaning that the DMPO, the optimization techniques, which were deployed even with all of these red and yellow problems, for example, packet loss or jitter problems, then the DMPO overcame these problems. And for the end user, in this particular for voice, or even we can have a look at video traffic, which probably the underlying connection it's even worse, because video takes up a lot more bandwidth than there you go, it's all red. So if we did not have DMPO working here for any video traffic, for example, webinars or video Zoom conferences or team conferences, then it would be impossible to actually use that video conference. But with the DMPO technology, you can actually see that it's the end user quality is actually green. It's 10 out of 10. It's perfect quality, and it's working. Please also remember this: we have a single connection here, so it's not even rerouting traffic or dynamically sending traffic from one link to another. It's actually optimizing the traffic on this single link, on this single wireless link. And after the optimization techniques, you are actually getting perfect quality connections for your video traffic through the technology of DMPO. So So this is a very powerful technology which you can actually deploy, especially for those locations where you only have wireless connection or satellite connection, and you need to overcome underlying problems, or even if you're in a rural area and you have a old DSL line or ADSL line which is having constantly problems, deploy SD-WAN, VeloCloud with the DMPO, you will overcome these problems. Additionally, you can also have the wireless and the DSL. If you have two links, then it's even better. It will dynamically steer the traffic up through the best underlying link, plus deploy all of the DMPO error correction features as well. So that would be even better. But if it's not possible, then even on a single link, it would enhance your quality. So we're going to move on here onto the actual links tab. On the links tab, it's basically our information on the traffic which is being transferred on this underlying link. Here we have a number of information we can have a look. For example, the best, I guess, is the average throughput on the link. We can see it's just under 1 meg being used. At this location, it seems that the link was being used to about 3 o'clock in the morning, 3 a.m. So people working quite late at this location. Then it went quiet, and then it restarted again just after 10 this morning. So people back at work just after 10 started using the site again. But it's not being used a lot. It's just 1 meg link at the moment. But additionally, you can have a look at past traffic information. For example, if those are any bandwidth changes, this is particular true if you're having a wireless connection, an LTE 5G connection, because the bandwidth changes a lot. Here it's pretty steady, around 15 megs available. Or also have a look at the actual packet loss, which we had on this link. Terrible. So you can actually see this link is not working very well at all. We're having packet loss around 1% packet loss almost all the time on this link. If we go to paths, then our paths are basically our connections, our overlay VPN connections, overlay tunnel connections. From this location, we actually have connections just to our cloud gateways. Our cloud gateways are basically gateways which improve the quality to our SaaS applications. So our cloud gateways, there's over 3,000 cloud gateways deployed globally. Majority of them are actually deployed within major data centers, housed in the same locations where we have our SaaS applications, where we have Microsoft, where we have Google, where we have Amazon. And some of the cloud gateways are even pairing with these SaaS applications. And then our SD-WAN edges, all of our locations, they connect to these cloud gateways. They're using all of the DMPO features for the optimization. And then from those cloud gateways, it's a simple hop onto our SaaS applications. A simple hop to Microsoft Office 365, or a hop onto Amazon Web Services, or I don't know, onto Zoom, for example, or any kind of SaaS applications which we use, Salesforce. Then that's how we basically get our enhanced connections to our SaaS applications with the power of DMPO optimizing that traffic, and also our fabric, our SD-WAN fabric connecting to these gateways, which are pairing basically with these SaaS applications. And here we can actually see we have two gateways where this edge is connected to our London gateway and to our Dublin gateway. We can get a little bit more information. For example, our London one, how much traffic is going through this gateway, which underlying link it is using. And then additionally, also, we can pull the DMPO, the quality service to this gateway. We can see that the free 5G unlimited bandwidth, broadband or wireless connection is not working very well. But again, with our DMPO, it has enhanced our connection to this gateway, to the single gateway, quite a bit. Additionally, with our Dublin same story basically. And then also the bandwidth, which is actually being used to this gateway. If we move along, we get our flow information. Our flows are basically our traffic flows. We have lots of information in regards to the source IP, from which IP address is connecting to what other IP address, the destination ports, the protocol, the segments, which link it's going through, a lot of information, which application it's actually being used for this connection. Additionally, we can actually search for particular information if we possibly want to have a look, search for a certain application where is for example, I don't know, let's take we can see here eBay, so we actually try search for eBay. It will actually look for that. Here we go, apply, and then we get all of our flows which are actually flowing to eBay. We can actually see how that was actually being connected, and we can actually see that was actually being routed directly through the breakout, meaning it did not utilize the gateway because it's not a business critical application. It was basically sent straight out to the internet from the edge itself, and how much traffic it was actually sent. If we move along in regards to the applications, here we get a list of all of our applications which are actually being used at this location. Similar information where we had under the links, but this is more information on the actual applications being used. So for example, again, you can see that someone was working here till about 3 o'clock in the morning, then again started again around 10 this morning. But then we have a list of all of the applications actually being used. So let's have a look back a little bit. This was the last 12 hours. If we have a look at the last maybe 24 hours, we actually can see that if we scroll down a little bit, what are the most used applications again, and when was this used? So we can actually see, well, someone was actually watching TikTok in the last 24 hours. Also, we can select the last four applications, or we can select 4 applications. If we actually just have a look at TikTok on its own, there we go. We can actually see what here someone was actually watching TikTok yesterday around what's this 1 p.m. But then we also have all of our business applications. For example, Microsoft. We can see actually someone was connected to Microsoft 365. Someone was actually, this is Microsoft 365 here, using Microsoft. Maybe we also have here remote desktop from VMware. So Horizon, for example, again, we can have a look when that application was being actually used. And then we have a whole list of the applications actually being used at this location. So very in-depth information. If that's too many applications for you, we basically can also categorize those applications to certain categories. Here we have tunneling and VPN. Let's turn that off. Social media. So here it will categorize all of the social media which was actually being used, for example, TikTok, Twitter, Facebook. If we turn off the web traffic and the infrastructure, here we can actually see when was social media actually being used or connected to from this edge connection. So here we can actually see a little bit of social media going on within this location itself. So very powerful information. From this, then you can also analyze how that traffic was being routed. Possibly you want to prioritize some other traffic, or maybe you want to even use the edge firewall to possibly block some of this traffic as well, if you see some of the traffic against your business policies, for example. If we move along, then we have our sources. So sources, basically all of our connections or all of our devices at this location. We only have 2 devices. We can also turn them off themselves. The SD-WAN control is the edge itself. So it also categorizes its own traffic. So we can turn that off. And really, we have one device, 10.11, which has been consuming most of the connection, most of the bandwidth here. We can go into a little bit deeper as well for this single device. If we go in, we can actually see the top applications that this device has been using. So here it's Microsoft or some CDN media content from Cloudflare. We can also see the top destinations. Again, Microsoft, Broadcom, Twitter, and some private IP addressing as well. So some connections internally. It's all being monitored, and this is for this single device as well. If you want to get deeper information for this single device, for example, all of the applications, you can actually click this little arrow here, and it will basically filter all of the applications for this single device. So again, we have all of the applications and when was this actually used on the graph here itself. Again, we can have a look at the applications or categorize those applications. On the other side, from the sources, we have our destinations. Destinations is showing us information where that traffic is going to. So again, we can have a look. We can see that majority or high amount of traffic has actually been destined to TikTok, CDN, to Microsoft, to Apple. These are the top destinations for a device. Again, we can go in a little bit deeper, see, for example, for this actual destination, what is the top application for this destination? Because the destination is TikTok CDN. So it's a CDN for TikTok, and the actual application is TikTok. And which device was connecting to most to it? Again, it's our 10.11 device on the LAN, which was connecting to it. We can actually have a look at the domain, the fully qualified domain name for these destinations, or just the IP address if we want to just have a look at the IP address itself. So here we have a list of the IP addresses connected to it. Business priorities, again, the edge prioritizes traffic based on application. There are 3 priorities. So we have our high, normal, and low prioritized traffic. Most of our video, real-time audio traffic, business application, Zoom, Microsoft Teams, this is usually high prioritized traffic. But all of our maybe social media, shopping sites, those are usually low. And then we have something in between as well. Control traffic is basically our SD-WAN traffic, which we can switch off here. And then it basically shows us what type of traffic is actually being sent the most. And majority of the traffic is actually normal to high traffic, and we can actually see that traffic actually being when that traffic was actually being sent. If we have an edge which is set up in a high availability setup, if we have an active edge and a standby edge, they are connected to each other through a back-to-back connection. Here we basically have the information on which edge is active, which one is standby. Additionally, if we have like a advanced HA setup, meaning that we have one underlying link connected to one edge, the other one going to the other edge, then going through the standby edge to the primary edge, we can actually see that all of that information here, which edges or which interfaces are connected to the WAN and how that WAN status is actually working. We don't have any, unfortunately, or we don't have in Manchester a HA setup, so we don't actually get information here. And then our system traffic is very useful in regards to the utilization of the physical edges and also the virtual edges as well. In regards to the CPU utilization, here we can actually see that the CPU utilization is below 30%, which is okay. Our temperature of our edges with our CPUs, the memory used, so here we're actually going up to almost 75%. So Possibly there's a lot of connections, lots of traffic. Possibly we might want to look into upgrading this edge if it goes any further or higher. And then the number of flows which are actually being connected. We also see the number of drops. If we have any packet drops, also this depends on the utilization of the links, and then also the number of tunnels connected. So here we have 2 tunnels. These are most likely the 2 gateways which is connected. And this gives you very good information in regards to the actual health of our edges. Possibly if we need to replace them, upgrade them, then we might want to keep our eye on the systems tab. So that's all of the information in regards to the monitoring. As you can see, we have a lot of information in regards to what is actually happening on the network. We can actually see which users are using most of the bandwidth. We can actually see the utilization, the applications. Possibly based on all of this information, we might want to upgrade our underlying links, possibly apply any new business policies, possibly apply any firewall rules. So how do we actually do all of that? After monitoring our network, how do we actually make any changes to our network? So this is pretty simple. First of all, we will go to our configurations tab on the top. Maybe just a few words in regards to how do we actually get one of these activated. So these boxes are usually shipped directly from Digital Carbon to the site, or from the factory, and they are not configured. They are not configured at all. This is all about the zero-touch provisioning, because they will basically provision themselves. We do need to do some basic setups in the orchestrator, and this is basically on our profiles. So under the configurations tabs, if we go to our profiles is a list of templates or pre-configured configurations which our edges will actually deploy. All of our edges have to be connected or linked to a certain profile. We can have different profiles depending on the requirements for that site, which connections we have, if it's a hub site, if it's a branch site, if it's a site possibly in Europe, if it's a site in Asia. All of this, we basically have a different profile. But one edge has to be connected to a profile. And then we have to remember any changes which we do actually within the profile will automatically be pushed down to all of the edges which are connected to this profile. So here we already have our pre-configured profiles. For example, we have our Microsoft Azure profile. This is our profile which we use for our virtual edges, which are actually deployed within Microsoft Azure. We are then able to connect that virtual edge to our SD-WAN fabric, and then make any changes basically to that one or a few edges which are the virtual edges. We also have our profiles for our different industries which we manage: manufacturing, construction. And here we actually can see that in our construction profile, we actually have 4 edges. If we actually have a look a little bit deeper into the actual profiles, this is where we have all of our pre-configured templates of configurations. We can start off with the VLANs, which we actually have on this location. We actually have 2 segments. So please remember our SD-WAN, we have an SD-WAN fabric, we have an SD-WAN network, but we can also segment that network into a number of segments. Each segment itself can have its own profile or its own set of configurations. So for example, if we have one edge, we have a number of ports on the back. Each port can be connected to a separate segment, and that segment would be basically isolated from the rest of the segments. So we can have a segment for public guest Wi-Fi, or a segment from one department, from the finance department to the sales department to the operations department. So all of this traffic can be segmented. Or we basically hit and have one segment. In this example, we actually have two segments and two VLANs. One VLAN is actually our standard data segment, and our second VLAN is our voice VLAN, which is connected to our voice segment. So our voice segment only handles voice traffic. Management IP is just the IP address for managing the edge devices. Up, timeouts we can set ourselves, but here we just have our default. The important part is our actual configuration of our network interfaces. Here we have an Edge 710 5G. So this is a 5G enabled Edge where you are able to plug in two SIM cards, 5G enabled, and automatically connect to the wireless network. And here we have four basically ports. Each port can be configured either as a switched port or a routed port, depending if we are connecting possibly to another switch, or if we have our end users connecting directly to the edge, or if we are basically connecting the edge to another modem, to a router, to a firewall. That would be more used than in a routed fashion. We also have SFP ports, where if we have any ADSL or optical interfaces, we are able to basically plug in the needed interface. And then our cell network. So our two SIM cards we have, which we basically connect, and that's used for WAN only connections. If we actually have a look at our interface, interface 1, Gigi 1, this is our switched port. It's an access port. We can also configure it as a trunk port if needed, and the VLANs which are actually connected to this switch port. If we actually have a look at a routed interface, then a routed interface gives us a little bit more information or a little bit more options. For example, if we need to enable our overlay traffic, this is enable WAN link, then this is where we basically connect to our cloud gateways or to our hub sites. We also have our IP information, for example, if it's a DHCP IP, to get automatically the IP address, or if we can we can put in a static IP address if needed. Then we can also enable OSPF. We can also enable multicast. We can advertise and then NAT that traffic as well. All of the edges are also IPv6 enabled. So if we use IPv6 within our network, then we basically configure it here for our interfaces. And then a little bit further down, it's just information on the layer 2 settings as well. So once we have that configured, we can move on to, if we are using IPv6, then we have some IPv6 information. Some of the edges, depending on the edge which is actually being deployed, some of them are also have a Wi-Fi connection for the LAN connection. The newest Edge 710 is Wi-Fi 6 enabled. The rest are Wi-Fi 5. But we can also have that configured. If we are connecting directly to the internet, I would recommend also to enable the common criteria firewall rules. This will automatically protect that edge from any malicious traffic coming to the edge if it's connected directly to the internet. And the most important part is actually the VPN services. So this is the overlay network. Once we have the edge connected, it will create the overlay network connecting either to our hub sites, connecting to the cloud gateways. Here we specify how we want the topology to look like, how the edge should be connecting, where it can communicate. So, for example, the first part is if we are using a hub and spoke topology. Obviously, in the middle we have our our hub sites, our data centers, our headquarters. This is where we enable our branch to hub sites. We need to specify what is our hub site, and then automatically we have a permanent VPN tunnel, a DMPO tunnel going to the hub site. We can also specify them as a backhaul hub, meaning if we want to backhaul any internet traffic, instead of sending it out directly to the internet, we can basically backhaul that traffic to a centralized site. Maybe we have a centralized firewall within that site and we want all internet traffic to break out from that location. Then we also specify that as a backhaul hub. Generally, we want internet traffic to break out directly or to go through the cloud gateways instead of that hairpinning, which old traditional networks do. We want to basically try to avoid that, but possibly there is certain traffic which we want to backhaul. We don't have to backhaul all traffic based on the business policies. We can backhaul some traffic. Next part is basically if we want to allow our branch to communicate to another branch site, we can enable this traffic to go through the cloud gateway. So one edge will send traffic to a cloud gateway. From that cloud gateway, we'll go down to another branch. If we have enabled dynamic branch-to-branch sites, then it will try to connect directly. The initial traffic will go through the gateway. Once that traffic is flowing, it will try to connect a direct encrypted tunnel between the two edges. Once that direct dynamic tunnel is enabled, then that traffic will reroute. It will lower the latency. It will provide better quality. And then once that traffic stops, after a few minutes, that tunnel is teared down, meaning basically we save resources on the edge. We don't need so much memory. We don't need so much CPU power. Because these are dynamic tunnels, they are only turned up when they are needed. Tunnels to hub sites and to cloud gateways, they're permanently up. And then also, if we want to allow our edges to communicate to a non-SD-WAN site, for example, a location which is outside the SD-WAN fabric, maybe a legacy data center, maybe a partner data center, then we basically can enable that here. Here we have an Equinix data center. If you can remember from the beginning, we had a VPN tunnel set up from the cloud gateway to this non-SD-WAN site. Then all of that traffic using DMPO goes to those cloud gateways, and then it's a simple hop through the VPN onto that non-SD-WAN location. We are able also to connect or create VPN connections directly from the edge sites. Here we configure any clusters, and then also if we are using a cloud security provider, for example, Zscaler or Semantic cloud services, we are able to basically get that configured, enabled here. Those tunnels are then automatically configured and set up. If we are using Zscaler, then also through APIs, through credentials, which we can put into the orchestrator, will automatically connect. We're going to move on a little bit. So here we have a look at all of our business policies. Business policies are QoS. Here we can actually see these are predefined business policies, so we don't actually have to set it up all the time. We basically then customize these predefined business policies depending on our customers' requirements. Maybe there's certain applications which need to be routed in a certain way. If they need to go directly to the internet, if they need to go through the cloud gateways, if they need to go through the hub as a backhaul, this is where we actually have it all set up. And for example, let's take our business applications. We can actually see all of our business applications. This is a category of applications. If we actually have a look at these applications, we can see these business applications, for example, MyQSL, SQL, SAP, or any other Microsoft SharePoint, Salesforce. These business applications, we can actually see that the way we actually treat them is that the priority is high, so they get the most priority over the bandwidth. It's using the multipath service, meaning it's going to be going over the overlay network. If it's SaaS internet destined, then it will utilize the cloud gateways. Otherwise, it will go back to the hub sites. And steering is automatic. So depending on how many underlying links we have, it might automatically basically steer that traffic depending on the quality of the underlying link itself. And that's all of the business policies. If we move it down a little bit more, then we actually see the mapping of those three policies. Like I mentioned before, we have a high, normal, and low priority traffic. High prioritized traffic is usually real time or class of service, class of application. If it's real time transition, real time, for example, voice video, transactional, for example, maybe SAP or Salesforce, and then you have bulk, for example, file sharing, downloads, and then we have our prioritization for high real-time traffic. It gives us like 35% of the bandwidth guaranteed, and then if we actually have a look at bulk, low prioritized traffic, it only gives us 1% guaranteed. Obviously, if the bandwidth is available, you get more bandwidth, but if we are using all of the bandwidth, then our real-time high prioritized traffic would get more of the bandwidth. And this is customizable. We can actually change this as well. So if we're going to move on to the edge firewall itself. So there's a number of security features which we are able to enable within the SD-WAN orchestrator. The basic security feature which you get with a standard SD-WAN license is the standard SD-WAN firewall. Additionally, we can enable enhanced security, which is an additional license. And we'll actually go through this through our next webinar. But we're just going to have a look at the standard firewall, which is enabled with the standard license, the SD-WAN license at the moment. So here we can see that actually we do have our enhanced security. Like I mentioned before, this is additional license. If we want to enable this, we enable it here. We have our intrusion detection prevention systems. We have our URL filtering, our malicious IP filtering, and we basically enable that here. And then we want to actually set our rules. The firewall which is available on the edge itself is a stateful inspection firewall. This gives us additional security features, for example, network protection for common known attacks, TCP-based attacks, ICMP-based attacks, IP address attacks. And this is where we are able to basically protect our edge from these attacks. But if we actually have a look at the actual firewall rules themselves, we can actually see here we have two rules only on the edge: security monitoring web traffic, and also we have our second rule, which is basically to allow all of our traffic to go through. So an example how we set up a rule, as we saw in our monitoring, that some people were actually using social media. Possibly we for our business policy, we are not allowed to allow employees to watch media, social media. So we want to maybe block that traffic. So for example, we want to block social media traffic. The IP traffic is IP version 4, IP version 6, source, any source or device connecting to any destination. And basically we want to block on the application. So a layer 6 application block. We want to actually define the application. And here we can specify a particular application. For example, maybe Facebook, Mail, Facebook CDN, or all Facebook, Facebook Live. So we can allow certain applications or a category of applications which we want to block here. So, for example, social networking. And within social networking, again, we have all of our social networks applications. We want to block all of this. If we are using MPLS, we can also set up a DSCP tag, which we're not allowing. Here, what kind of action? So here we want to actually drop that traffic. If we want to log it, we enable loggings. It gives us some, if we want to put a comment for this rule, we can. And then we want to create that rule. And so here we have our blocking of our social media. Now, if you can remember, we actually are doing this in our profile, not on a certain edge. If we're doing this on our profile, then this rule is actually pushed to all of the edges on this profile. So we're going to save these changes. Automatically, this rule will be enabled on all of our edges which are connected to this profile. We're going to move on quickly. Overview just gives us a quick overview of the configurations, what is enabled, what is not enabled. So we have all of that an overview here. We actually are going to go now back to our edges because we want to basically enable a new edge. So we're going to pick a new edge. We want to give it a name. Let's say this is going to be a Bristol site, a site in Bristol in the UK, a model of the edge which we are deploying. So we're going to deploy a 710 5G enabled edge. And this is where the profile we're actually going to choose. So that was a construction greenfield location. Obviously, we need to select our licenses. Here we just have a POC test license. And then we also provide all of our user information. We click on next. Here we would create the serial number of that edge. If we have the serial number of the edge, this will give us a true zero touch provisioning, where basically we strip out the edge. The edge will connect to the internet, or if it has the 5G connection, it will basically connect to the internet, and then it will connect to the orchestrator. The orchestrator will look up what serial number is on that edge, and it will automatically push that configurations down. Unfortunately, we don't have the serial number, so we're just going to add it without a serial number, and this will give us the one touch provisioning, meaning basically if we go back to our edges, we see we have our Bristol sites here. If we want to actually get this enabled, then if we go to the overview part, we basically send an activation email. This will go to a user which is on site. The user on site will receive this email, and there is an activation link here. So it gives us the instructions on what to do. We basically get our edge, we plug it into the internet connection, or if we have a 5G or 4G enabled edge, it will automatically connect to the internet. Then our users on site would connect to it through Wi-Fi or through a LAN connection. Once connected through Wi-Fi, all they need to do is click on this activation link, which they will get through the email. And then with this activation link, it will tell the edge to go to this orchestrator to pull down this configurations. And that will automatically pull down the configurations. It will configure itself, and we will have a fully managed site within a few seconds. And then once the edge is up and working, then it will turn up here within our monitoring, and then we'll be able to do any additional configurations if we do remotely through the orchestrator. Just to finish up, a few words in regards to the diagnostics. If we are having any problems with edges, then we also can have a look at the diagnostics. We can do a number of remote actions, switch the edge off, reboot the edge, restart the services. If we want to go a little bit more deep dive, possibly do some troubleshooting, maybe BGP routes troubleshooting, or connection, or ARP, or to find out what is actually happening on the edge itself, then we simply can connect through the remote diagnostics tool. This will give us a list of a number of commands which we basically send from the orchestrator to the edge themselves, and it will provide us information on what is actually happening on the edge themselves. It takes some time. It can take up to a minute basically to connect, because it's trying to do a real-time connection, so it may take some time. Unfortunately, our 1 hour webinar time is up. Hopefully you enjoyed the webinar. Hopefully it is very useful. It showed you a little bit more how you can actually manage your network remotely. Please remember, we provide a co-managed service for VMware, VeloCloud, SD-WAN, and SASE services. Not only the SD-WAN part, but then we also have the SASE with the cloud web security, with CASB, with antivirus, anti-malware. Then we have our remote VPN, so SD access, which your remote users are able to connect into the SD-WAN network themselves from remote sites. All of this is managed from the one and only SD-WAN Edge Orchestrator. And I encourage you to contact us if you want to go in a little bit deeper in regards to any of the features which I showed. Hopefully you'll be able to join us next week in regards to our enhanced security features, where we will have a more deeper dive into the actual security and the edge security and enhanced security features which we have on the edges themselves. If you have any questions, please do not hesitate to contact me. My name is Mark Bursky. You can find me on LinkedIn. Hopefully it was very useful, and have a good day. Thanks.